Alright, hello everyone. This is EECS Discussion 9. Due to some logistics issues, I'm going to be moving the discussion on UI stuff in Unity to next week. This week I was going to go over a short presentation I made about, tips I wish I had at the start of Project 3 when I took 494, seeing as you're just in your second week of Project 3. Hopefully having these tips will help you. It's just kind of a collection of different stuff that kind of came back to really bite me and my team, and made us lose a lot of time later in development. And, thinking about this earlier on will definitely help you quite a bit. So starting off, I wanted to talk about some logistics with just using Unity. The first thing, hopefully you've already done this, but agree on a single version of Unity to use, and please don't upgrade Unity versions during Project 3. For whatever reason, we had some sort of bug with one of the Unity versions that we were using, and our team decided to update to the next version of Unity during the project. And if you're having bugs with the current version of Unity, sometimes just sticking with those is better than the headache and pain you cause yourself by upgrading. So I would definitely recommend keeping that in mind when you're working. If Unity says, hey, there's a new version, just please click skip new version. Ignore that. Don't use it. Don't fall for the trap. That was the first thing I wanted to mention. The next thing I wanted to mention that might not have been thought of yet by your team is the render pipelines. So the render pipeline is sort of all of the the graphics rendering code that Unity uses for your game. If you use a default 3D or 2D project, you're going to use the Unity built-in render pipeline, which I'll pull up here. Which is kind of general purpose, is kind of made to be used for, everything. It doesn't have as many features as some of the other rendering pipelines I'm going to show you. But you can extend its functionality if you write your own, these things called command buffers, which can be a little bit confusing. I've not personally worked with command buffers, but this is a thing if you're using just a built-in render pipeline and you want to extend its features. So I personally would recommend, if you are interested in trying things like shader graph, which, if you remember, the shader graph is it's the feature of the Unity editor that lets you build shaders without writing code. It's like a visual editor for shaders where you put graphs. You make a graph with a bunch of nodes, and each node has a different effect on it. Things like this are available in currently 2 render pipelines, the universal render pipeline and the high definition render pipeline, or URP and HRP or HDRP for short. So I personally, for 494 projects, would recommend URP over HDRP. For a few reasons. The biggest reason being that currently URP is the only one of these two that supports 2D projects. HDRP, as far as I'm concerned, if I remember correctly, this should still be the case that it really only supports 3D projects, and if you're a team using a 2D project, HDRP is automatically disqualified. If you are doing a 3D project, the reason I would discourage you from using HDRP is because it's kind of targeted towards high performing PCs and Xbox and PlayStation. If those are just your 3 targets, it requires a lot more effort to fully utilize all of its features. You have to have all these different texture maps and different mappings, and there are all these features like screen space reflections. They're cool features, cool graphical features, but the cost ends up being that you might have a lot of other people in the class who might not be able to run your games very well. So they might have a degraded performance, and they won't get the best game experience when they're playtesting for you. That's one thing. The other thing is it's a lot more effort for your team to to try and utilize all of the features of the high definition render pipeline. And the URP, it's not like you can't make really good looking games using the universal render pipeline. So actually, I will put a link to this in the description of the video. But so Brackeys, which is that Unity YouTube channel I mentioned, has a video about URP versus HDRP. It's about 8 minutes long, and it covers some of the same content I probably just mentioned, but it also
before when creating
oh
a new Unity project, you got to choose between 2D.
I don't really want to play the audio right now, but I'll link this in the description. It's a great video to help you kind of show you the difference between URP and HDRP, but really again, I would recommend thinking about URP for this. So, that being the case, if you aren't currently using the universal render pipeline, you're just using, one of the 2D or 3D project templates when you created your Unity project, fret not. You can install URP into your project. I will link this document in the Unity manual in the description as well. You have to install it through the package manager, and then you have to create a URP asset for your global rendering, and then you should be able to use all of the features of the URP. If you want to compare the two, the URP has, like I mentioned, it has a shader graph, and it has a lot of other features as well, which you can sort of compare the built-in render pipeline to the URP on this table here. So I know I've been harping on render pipeline.
Question.
Yeah, go ahead.
So if we're currently on the universal render pipeline, but we don't think we're going to use many of its features, should we downgrade? Would that increase performance?
Currently the universal render pipeline is extremely performant in a lot of cases, even compared to the built-in render pipeline. Like, for I guess the games that you would be making in 494 Project 3, just being familiar with the scope of projects in the class, you're not going to see very many performance hits by using URP over the built-in render pipeline. So downgrading from URP to built-in render pipeline probably isn't worth the headache that it likely is. You're not going to see that much of a performance difference, at least.
Okay, thanks.
If you are having performance issues while with builds made using URP, then that might be a different problem, and I would recommend first using the profiler to kind of maybe see what's going on with your game. But at that point, maybe you might want to consider it. But again, it's really URP tends to be pretty performant, so it's not necessarily that big of a concern, hopefully. Cool, great question. Yep, I will move on for now from render pipeline stuff. So the next kind of logistics thing is related to source control and merging. You've heard this already. I know I've been mentioning it since Project 1, but please use separate scenes for each team member. This will just, even if you're using the student developer pack. By the way, actually, let me go over that first. I'll put this up here. Student developer pack. This was mentioned in Twitch chat during lecture one day, and I think either on Piazza or the Discord, but there's this thing called the GitHub Student Developer Pack, which if you have an edu email, which all of you do, it's your unique name at umich.edu, you can get this free developer pack. And part of what this gets you is you can go to Unity once you have created your GitHub your GitHub account. Once you link it to your Umich email, get the GitHub Student Developer Pack. Let me find the thing here. there's the Unity Student Plan, it's called, which you get access to this if you have your GitHub Student Developer Pack. And then, okay, I know. And what this gets you is the ability to use Unity Collaborate as your source control with more than 2 people. I think you can have up to 5 people on a team with 5 seats of Unity Teams Advanced. So really only one person in your team needs to do this, and then that person can create the Unity team for you guys to use Unity Collaborate with. But if you would like to use this instead of Git, which, I mean, using Git is totally fine, and you can make it work. Unity Collaborate might be a lot smoother in terms of merging scenes if you end up doing things where you are working on the same scene. Again, links to these I'll put in the description for sure so that you have access to them. But even if you are using Unity Collaborate versus Git, still I would recommend keeping separate scenes for each team member, because what might happen is that a merge that Unity Collaborate does might delete the wrong things, and it might not do what you want it to do. So having everything in separate scenes and then bringing them all into, a master scene that no one really works on until, you're merging your stuff together, that definitely will ease your, your collaboration woes with, teaming up and getting all your project work done. On that note, I would recommend to consider, thinking about starting merging stuff together on Saturday instead of Sunday. In this class, deadlines for, Project 3 deliverables tend to be Monday morning at 11:30. A great formula for a potential all-nighter is to start your merge on Sunday evening and then run into an unexpected issue, and then just stay up all night getting everything merged, and you only end up submitting at 8 a.m. Not a great time. Speaking from personal experience, it wasn't good. So I would recommend, in the chance that you might have some conflicts, to think about merging stuff on Saturday. Of course, if you're not ready to do your merging on Saturday, go, take your time. But I would recommend trying to schedule the work that you do during the week asynchronously to kind of start synchronizing on Saturday instead of Sunday to just prevent problems. So that's all I'll say about that. I feel like I've made my point. In terms of merging, I just kind of wanted to put my personal recommendation in terms of what order to do manual merges. I would say start with your scripts, because there's kind of a dependency in-game. Things in the editor depend on the scripts existing. So starting by putting the scripts in first, which don't depend on things in the inspector or in the editor, and then moving on to your raw asset files, which, like scripts, your textures, your audio files, your sprites, those don't depend on anything in the editor, but the editor depends on them. Put this stuff in first. Your IDE will definitely immediately tell you about any compatibility issues with your scripts, if your interfaces are mismatched, if you don't have the same public variables across people's different versions that they were working on. This can pretty quickly be checked with compile errors in your Visual Studio Code or Visual Studio proper, or whatever IDE you're using. Again, raw asset files, and then finally your prefabs and your game objects, bringing them into the scene. I would recommend saving that for last, as just sort of a general guideline for how to do merging. Cool. I think that's all I had to talk about in terms of logistics with Unity. The next thing I wanted to tell you to think about is your control scheme. I know that at the beginning of Project 3, things can be very feature-heavy and game mechanic heavy, where you're focused on like the technical implementations of getting the game mechanics working. You had your gold spike. Now you're iterating from there. You're trying to make the game. but it can be because of that, it can be easy to forget the actual, like, the input scheme that players are going to be dealing with when they play your game. I would recommend spending some time as a team discussing this. Um, you want to really have a control scheme that's easy and accessible. And it's you can, I guess, it's really worth thinking about this early on as you're coming up with new mechanics, so that you don't end up having to completely remap everything later. So, some of the things you can think about with your control schemes: does the player have to move their hands a lot to hit the keys? If so, you might want to consider, thinking about your controls. If your game mechanics and your controls for your game don't require the use of a mouse, consider making your UI also not require a mouse. Because one common problem that I guess I've seen in a lot of Project 3 games is where the game itself doesn't use the mouse, but to control the UI elements, to click on buttons in the menus, you do have to use your mouse. Obviously, if your game uses both mouse and keyboard for controls, you're going to want the player's hands to be on the mouse, so having UI controls that use the mouse are perfectly fine in that case. I would suggest thinking about what I call control tropes, and what I mean by that is just really commonly used, sets of control schemes for, many games in the industry. For example, some people like to use WASD for movement, especially for mouse and keyboard games, where in a 3D game you're using your mouse to move around the camera, and you're using WASD for move. You can use, for example, E for other actions, Q for other actions which are above D and A on a QWERTY keyboard. R is a common button for reloading if your game has, guns or ammunition. F is also a common key that's used in WASD-based movement schemes, because these are all keys that are right next to WAS and D. So for that, I would recommend that. You'll see this a lot more with 2D games, because the arrow keys are on the right side of the keyboard, and that means usually someone's right hand will be using it. Either they would have their hands on the mouse or here on the arrow keys. If you have a 3D game that doesn't really have camera movement, then you might see this being used as well. But the arrow keys plus Z, X, and C is you may have you may be familiar with this from Project 1, but this is actually, it's a fairly common control scheme in 2D games, other than your 494 Project 1. The third thing I put here, space jump. This is pretty universal in most control schemes. If you have a jump, space is a pretty good button to pick for that. People's thumbs naturally rest on the space bar when they're at the keyboard. So having that as an option is a pretty good choice. The other thing I wanted to mention is, if you are considering making your game have a controller-based control scheme as well, first off, remember that you're not required to have a controller-based scheme, but you are required to have a mouse and keyboard-based scheme. But maybe some of you might want to have a controller scheme as well, because you think it'll result in a better experience or something like that. Generally, with this is mainly kind of based around my experience with 3D games, this advice. So I would recommend moving WASD to the left analog stick, your mouse movement for camera on the right analog stick, and then whatever actions were mapped to your left mouse button and right mouse button, I would recommend moving those to some of the trigger buttons on the controller. And the reason for that is that when you're on mouse and keyboard, the player can move the mouse at the same time as clicking the mouse buttons. And if you were to use some of the face buttons to replace the left mouse button and right mouse button actions, then it's a lot harder for the player to use the right analog stick to move the mouse and press those buttons. So you're kind of putting, people who are using controller at a disadvantage compared to some of the things that, mouse and keyboard users have access to. So by picking, the trigger buttons, which are using the index and middle fingers of like players' hands usually, while they're using their thumb for the analog stick, then you kind of get a controller scheme which kind of has a similar accessibility in that way to your mouse and keyboard scheme. In terms, and like the final thing I would suggest if you're on a controller, make jump the bottom face button. If you're using spacebar for jump, the bottom face button, which is X on a PlayStation controller and A on an Xbox controller, that's kind of the most intuitive place to put not just your not just jump, but also, let me put this here, confirm in menus is very commonly here, while B on the Xbox controller and O on PlayStation controller is going to be like usually for go back in menus. So I'd recommend for when you're designing your UIs to be used with controllers, to consider this as well if you're using a controller scheme. The next kind of tips I wanted to give you, or not tips, just like thing to consider early on, things that, you can end up saving a lot of time if you plan on, thinking about this early on, is camera movement. If you're working on a 3D game, if you're 3D third person, you kind of have a couple of options to think about. Either the player doesn't really have access to control the camera at all, and it just follows the movement of the player. Another possible control scheme for a third-person game is to give complete camera control to the player, where it just stays wherever the player puts it, and then they have to move it again if they want to move it. And you don't do any automatic moving of the camera at all. And the third option is kind of a combination of the two. If you look at games like Super Mario Sunshine or other 3D Mario games, they tend to do this, where the player can rotate the camera on their own time, as they want to. But if the player starts moving around and they're not controlling the camera manually, then the game kind of takes control of the camera and puts it in what it thinks is the best position. Some people don't like when this happens, but being thoughtful about how and when this happens can result in a better experience, because sometimes, you do know better than the player in terms of what you want them to be able to see. So having some control over the camera, even if you're giving them some control, might be worth considering. In terms of that, this was asked earlier in the semester. There is this Unity package called Cinemachine, which is super useful for just doing stuff with the camera. It's kind of designed for it's designed for like cutscene stuff and like filming, basically using Unity, but you can consider using it in your game as well for how you're controlling stuff relative to the player in game. So I'll put a link to this in the description of the discussion as well if you're interested. With 3D first-person games, usually you just have complete control to the player in terms of where the camera is positioned. With the mouse, usually, or like I said, the right analog stick. Finally, with 2D games, either there are kind of like two main ways that people approach camera in 2D games. Either the camera is going to follow the player around the stage, things like Metroidvanias or top-down games. You'll see this where you have a really large stage, so being all the way zoomed out wouldn't make sense. You're zoomed in on the player, and depending on whatever room they're in, the camera is following the player, and then they go from room to room. The camera follows them. The other kind of option that you might see is, with games like, Mario platformers, other games with platformers, is either the width or the height of the screen or level is fixed, so the camera never moves up or down. It really just moves left and right. this is sort of where basically the entire level is, or at least the part of the level the player is in, can be completely viewed from within the screen instead of, you're more zoomed in and can only see a smaller part of the level. I know that these might seem a little bit intuitive or obvious, but it still is definitely worth thinking about this beforehand rather than much later in the case that you pick kind of a less optimal way for your camera to be going. Because, the camera is the main way that your player sees the game, and having designing, I guess a camera that's the best for the game that you're trying to make, is pretty important to think about early on, I would suggest.
I have a question about this too.
Yeah, sure.
So right now we have a 2.5D, so it's top down, but it's got 3D assets, and we have different rooms. And right now, our handling transitioning between rooms is kind of iffy because we kind of follow the camera until it gets to a wall, and then we snap to the wall so that he can't see outside the room. But then when it switches between rooms, it like jumps. So do you have any advice for what we could do for that?
So is it you have the ability to check when the player is about to go between room from room, right? You have sort of like a collider in the doorway.
I could build that functionality.
So, I mean, essentially the key to making sure this happens the way you want would be to be able to keep track of when the player switches rooms. Because only when the player is in the next room is when you want the camera to go to the next room, right?
Yeah.
So I would suggest that sort of a maybe some type of collider or trigger right in the doorway that will trigger the camera to go in one direction or the other. Whether or not you want to, I mean, the hardest problem with this type of camera scheme is if the player stands in the doorway and then changes their mind and goes back out.
Yes, that's the current biggest issue.
So I would suggest being careful and thoughtful about using, enter versus exit with your triggers.
I think what I might do is just, when they're in the doorway, don't move the camera.
Yeah, I mean, I would suggest that as well. And then you have, I guess, yeah, if there's a trigger in the doorway, when they exit the trigger, you can check which side of the trigger they're on after they've exited it. Can't you? Because you have the transforms of the two things. And you can be like, oh, okay, so they've exited the trigger, they've decided which room to enter. If they're in the left room, put the camera in the left room. If they're in the right room, put the camera in the right room. Maybe that might work.
I use raycast to detect the walls.
Okay. I think that also might result in a similar. I think that's also a pretty reasonable approach to it.
The problem is when they go in the doorway, the raycasts don't hit the wall.
Got it. Yeah. So maybe trigger instead of raycast might help you out there, but it's definitely worth experimenting around and seeing what you can get going there.
Yeah. Thanks.
Yeah. Cool. Great question again. I think the last thing I had tips on, this is a pretty short one, but think about your research games early on. Think about, there are 8 games that you have to research. Because your team is so big, that's usually not a problem, just kind of two games per person if you're in a 4-person team. I would suggest doing this earlier on rather than later. This assignment, I believe, is due on November 10th this semester. Trying to complete it, maybe before, much before then instead of right before it's due. will be more of a benefit to your team because, you know, sort of the insights that you get by playing sort of games in the genre of game you're making, or games using the same, like, similar mechanics to what you're doing. The earlier you can kind of compare your game ideas to, you know, those actual finished products, the earlier you can kind of integrate ideas that you get from those games into your game. So I would suggest, you know, my I guess as the reason I'm suggesting this is my team, we ended up putting this off until like kind of the final weekend, and we, you know, ended up having to rewrite a lot of code that we had spent time working on in the previous week because we ended up finding a completely better idea for what we had done by playing these research games. So, you know, even for stuff like camera controls, which we were just talking about, or control schemes, those are two things that are really, really great that you can get out of every single game that you're doing research on, because the games that you research aren't necessarily going to be complete matches with what you're working on, but they all have control schemes and they all have a camera because you always have to be able to see the game. So looking at how their camera works and how their control schemes works is some information that's pretty useful to look at from every single game that you do research on. So I would suggest thinking about that, you know, as early as today, even whenever you're watching this video. But yeah, those are the tips and thoughts that I wanted to share with you regarding Project 3. Hopefully you found them useful. As I mentioned, I'll put a link to the stuff that I mentioned in the description. And yeah, I'm going to stop recording now. Thank you.